Chemistry powers today, but courageous chemistry is shaping our tomorrow. It's fueling the hydrogen economy and driving clean energy. It's in our semiconductors and even powers our 5G. It makes bridges stronger and medical equipment safer. Chemistry powers progress and binds us all together. But there's something more that sets us apart. Courageous chemistry.
Welcome to another interesting class. In today's lesson, we'll continue our series of separation techniques, okay? And we're beginning with separating funnel. Separating funnel is an apparatus that is used to separate two immiscible liquids. These two liquids do not mix together because they are different nature. It could be their polarity and their density also contribute as well. By polarity, I mean one is polar, the other one is non-polar. For example, water and kerosene do not mix together, okay? So when this happens, the two liquids, when you pour them together, they will separate into two distinct layers. The one that is more dense will be at the bottom, while the one that is less dense will be at the top. So if I pour water and kerosene together into a separatory funnel, which is a glassware, as you can see there, the water will settle at the bottom, leaving the kerosene at the top. I can now easily open the bottom tap of that glassware and allow the water to flow, okay? Then we look at sublimation. Sublimation is used to separate substances that changes from solid straight to gas from those that do not. A very good example is ammonium chloride. So if I have ammonium chloride mixed with sodium chloride and I want to separate both salts, I can just heat the salt. Ammonium chloride will sublime and then leaving sodium chloride behind, because sodium chloride is not decomposed by heat, is it not? Yes. So sublimation is a method used to separate substances that sublime from those that do not. Examples of other substances that undergo sublimation include camphor, iodine, ammonium chloride, naphthalene, and so on and so forth, okay? I want you to pay attention to this video to learn more about other separation techniques as well as the purity of a substance, okay?
Most of the matter around us is a mixture of two or more components. Mixtures are either homogeneous or heterogeneous. Homogeneous mixtures are uniform in composition like air, and heterogeneous mixtures are not uniform in composition like oil in water. Homogeneous and heterogeneous mixtures can be separated into their components using different techniques based on the type of mixture and difference in the chemical properties of the constituents of a mixture. Separating funnel is one of the techniques that is used for separating the components of a mixture between two immiscible liquid phases. One phase is the aqueous phase and the other phase is an organic solvent. This separation is based on the difference in the densities of the liquids. The liquid with more density forms the lower layer, and the liquid with lesser density forms the upper layer. Materials required: beaker, filter funnel, separating funnel, mixture of oil and water, and stand with a clamp. Procedure: first, take the separating funnel and clamp it on the stand. Now, take a filter funnel and place it on the mouth of the separating funnel. Pour the mixture of oil and water into the separating funnel through the filter funnel. Then remove the filter funnel from the separating funnel and close the separating funnel using a lid. Now, take the separating funnel from the stand. Invert the funnel and shake it gently and slowly open the stopcock of the funnel to release the pressure inside the funnel. Again, place the separating funnel in the stand and allow the two liquids to separate completely. We can see that oil forms the top layer and water forms the bottom layer. Now, take a beaker and place it below the separating funnel. Remove the lid on the mouth of the separating funnel. Open the stopcock of the separating funnel and pour out the lower layer of water carefully into the beaker. Close the stopcock as the oil reaches the stopcock. Take another beaker and place it below the separating funnel. Open the stopcock and now collect oil from the separating funnel. Finally, label the two components transferred into the beaker as water and oil. From this experiment, we can infer that the immiscible liquids separate out in layers depending on their densities. Since water is the denser liquid, it falls to the bottom and forms the lower layer. As oil is the lighter liquid, it forms the top layer.
Paper and thin layer chromatography, both of which are used in forensic science applications. Chromatography is a separation technique, and this will be demonstrated using food coloring. Using a pencil, draw a line at the bottom of a strip of chromatography paper. Dab a small spot of red food coloring on the pencil line and repeat with green and blue food coloring. Place this in a beaker with water, ensuring that the water level does not touch the spots. As the water is absorbed, it separates the multiple components of the food coloring. We have now created a chromatogram. The chromatography paper is called the stationary phase as it stays put. Water is called the mobile phase as it moves up the chromatography paper. Here is the key idea. A component that is more soluble in water travels a greater distance up the chromatography paper, and a less soluble component travels a shorter distance. The retention factor, or RF value, is a measure of the distance that a separated component has traveled compared to the distance that the solvent, in our example, water, has traveled. These distances can be measured using a ruler. What does the retention factor value tell you about the solubility of a separated component in the mobile phase solvent? Please pause the video to think about this and resume when you are done. A larger retention factor value means that the component is more soluble in the solvent. A smaller retention factor value means that the component is less soluble in the solvent. Thin layer chromatography, or TLC, works in exactly the same manner. Instead of chromatography paper, a glass plate with a thin layer of silica gel or any other adsorbent material is used. This thin layer of adsorbent material is the stationary phase. A suitable solvent may be used as the mobile phase. If the separated components are colorless, the dried chromatogram may be sprayed with ninhydrin, which can turn some components purple, or the chromatogram may be viewed under UV light. Ninhydrin is used to detect fingerprints from a crime scene. These chromatography methods can be used to identify and compare samples of drugs, inks, lipsticks, saliva, and explosives, just to name a few. In conclusion, paper and thin layer chromatography are used to separate components of a mixture based on their solubility. The relative solubility of the separated components can be determined by calculating their retention factor values. More soluble components have a larger retention factor value, and less soluble components have a smaller retention factor value.
Matter found on Earth can be classified as either a pure substance or a mixture. So let's take a look at the difference between these two. Welcome to Moo Moo Math and Science. A pure substance is either an element or a compound. All of the elements found on the periodic table are pure substances. They cannot be chemically separated. Compounds, which are elements bonded together, are also pure substances. For example, take water. It contains 2 hydrogen elements bonded to 1 oxygen. Carbon dioxide contains 2 oxygens bonded to a carbon. They require a chemical process to separate this compound. There are millions of compounds found in the world. Mixtures, on the other hand, are a combination of substances that can be separated physically. There are 2 types of mixtures: homogeneous mixtures and heterogeneous mixtures. A mixture that is uniform or the same throughout is a homogeneous mixture. You often hear them referred to as solutions. For example, let's take a look at Gatorade. It is a homogeneous mixture. gasoline. Alloys like brass, which is a mixture of copper and zinc. A heterogeneous mixture is one that is not uniform and is different throughout. Examples include a fruit salad. How about oil and vinegar? And then soil. Here's a simple flow chart that will help you classify something as either a pure substance or a mixture. Let's begin at the top. Can it be separated physically? No. Then it's a pure substance. A pure substance asks, can it be separated by a chemical process? No, it's an element. Yes, it's a compound. Now let's go back to the top. Can it be separated physically? Yes, it's a mixture. Is it uniform throughout? Yes, it's a homogeneous mixture. No, then it's a heterogeneous solution. Thanks for watching, and remember, kindness multiplies kindness. Be kind to someone today.